Hey guys. Hi, good morning. So today we're going to start talking about as introduction to the course. Okay, so this is Dr. Abdul Karim, or you can call me Dr. Karim or Sir. Okay, that's fine. So let's go and see what data mining is. So from the poll, what I see that many of you has answered given correct answer. So generally, if someone asks you what is data mining and how it's different than traditional programming, many of you probably have taken some courses in programming, right? They are familiar, they like coding, sitting long hours before the PC, writing codes, or maybe doing freelancer or whatever. So now the question comes in and say, okay, well, how data mining or machine learning is different than the traditional concept of programming. So here today we're going to talk about it and explain in more details. So firstly, the idea behind data mining is that the ability to automatically discovering useful information. We'll see that in soon how that means, but you can keep in mind when we talk about data mining or machine learning, that means we are talking about giving the ability to the machine, to the PC to do prediction. Now, if I give you, let's say, stock prices, right? And you need to do some programming. Now, if you need to do prediction, of course, maybe you take many figures, check about them, right? See how the prices are going up and down, and then you take many factors looking into it, maybe other stock prices and etc. And then you maybe also be able to have some prediction, right? That the stock price is going up or going down and etc. Okay, that's fine on the human ability we're talking. But now if we come to the machine, how you can tell the machine to predict, right? Can you tell the machine, okay, do same like me, check the figures and decide about the stock price or give me some prediction, right? This, I mean, just talking easy, but how you can transfer that to make the machine understands or do what it's supposed to do, right? So this is the big part where machine learning and data mining comes in to help to program or do a program that helps you to do prediction. So keep in mind when we talk about data mining or machine learning is the capability to predict the outcome or future observation. So what does observation means? So try to take notes. These are important. When I say observation, that means a new case. Let's say I want to ask my PC about the stock price for tomorrow. This is future, right? And the observation is the case. I'm talking about tomorrow. Or let's say today, maybe how the stock price will end at the end of the day. So I give some details. So far, how the stock is working or how is the stock is performing, what are the factors. Then I produce to the PC. Then I'm waiting the outcome. So the observation is the case that you are studying, or in particular to be, because later you will see that we say observations many times. So if you think of it like you have a table inside database, and then let's say you have the prediction for the stock price. You have one column there, and then you have a bunch of data there, historical data, some data for yesterday, and etc. and etc. So the case is, we can say, for example, is today price. This is one case. Another case is tomorrow price. Another case or observation. So we may say observation or case or object referring to the same matter. So you can keep in mind observation is like a row inside the table. Now I'm giving you all these details. Tell me what is the outcome. This is the observation. Okay, or maybe I'd like to predict the price of a house. Let's say I have built a program that is able to predict about the house price. Okay, so then I found a particular house. I need to predict the price of that house. That particular house is the observation. That particular house is the case that I'm looking to find the outcome of it for the future, for the house price, for the car price. So observation simply means the case, that particular house, that particular car I'm working on to predict its price. So you have built an application or a system or model, we usually say, to predict the car prices. So I collect many prices for many cars and all the other factors, whether it's sedan or not, the capacity of the engine, and etc. All this information I have collected. And this information, we call it historical information, historical data. Why we call it historical? Because simply it has already happened, already took place in the past. So what I mean exactly when I say historical, that means I got information about other cars have already been sold out. So I got all the information about the type of the car, the brand, the model, the year of production, uh, as I said, the capacity of the engine, and etc. and etc. and etc. Plus, I got how much it was sold for. So this is called historical data. So now I take all these data, I bring it to my model or to my application, nice, and I tell or I program, I do build up my model based on this historical data, right? And don't forget the car price is there because it's history. It's already sold. I'm not looking for future observation yet. This is history. It's already in the past, gone. So I introduce it to my model. My model will try to learn, to find something that can be learned from data to help me to do future prediction. This is the idea. So I bring historical data. Again, history, keep it in mind. That means something already happened, gone in the past. I'm not going to predict it. This is not the idea because it's history in the past, gone. So I take this data, I introduce it to my model or to my application somehow, in some way. We will learn throughout the course. And then that model will be able to predict for future observation. So again, the observation, let's say I built a model for car price prediction. That means the observation, let's say I'm going to sell this car. So it hasn't been sold yet. I'm going to sell it. So I need to predict based on all these historical data. I'm going to predict the price for this car. So I tell my model, okay, here are the information about my car. This is the brand. This is the model of production, the year of production, the model, the capacity of engine, blah, blah, blah. And then I tell my model, tell me the prediction for my car. How much would it cost or how much I can sell it for? Okay, is it clear when I say observation, what does that mean? So keep in mind observation or object or case or row. If you talk about using terminology for database, that means we are saying a row, an instance, a case study. Okay, guys, remember, I like to see you participate. If you have any problem, something not clear, maybe because I may suppose you this is clear for you, but it may not. So just you tell me, that's fine. As I said, keep this in mind. There's no stupid question at all. So the floor is always open to you and don't feel shy. And if anyone mock up you because you're asking questions, just you need to let me know. So just feel free and ask question in my class. I will be even happier. Is it clear what observation is? Okay, great. And historical data, something in the past happened. Where this is not my concern to predict for future. This is history. Okay, so this is what data mining so far. And then someone else also has defined it, saying it's the field of study that gives computers the ability to learn without being explicitly programmed. Now, this might be confusing. How without being explicitly programmed, right? This might be a little confusing phrase. I will explain to you, but let's take a break for 10 minutes and then we come back. I will explain to you what does that mean. So this actually will help you to understand how traditional programming is different, because there, would that mean that traditional programming, we go explicitly telling the application what to do, and now here we do not? Yes, you can say that. So we will see how soon after the break. So I'll see you at 10. And meanwhile, if you have any question, you can ask, you can unmute yourself, you can raise your hand, you can write in the chat box, wherever you like, you can write it on the wall. on your wall and turn on the camera, that's fine too. Okay, guys, let's carry on. But please, I still see not all of you has joined the group, Outlook group. So please, this is important. Make sure you have joined to the Outlook group. I'm already putting it in the chat box and the WhatsApp as well. So please join, especially the Outlook group, so at least later you get notified. You can see the recording for the lectures. So please make sure you join. Just finish it today, so later we don't need to come again talk about it. Okay. And also for those who joined late, this is the Facebook page for this course. We can also discuss there. Okay, so let's carry on. Okay, so just before the break, I was saying data mining or machine learning is the field of study that gives the computers the ability to learn without being explicitly programmed. So what does that mean? So if you let's say you want to develop an application, if we're talking about computers, right? Developing application, whatever language you are using, what do? Right? You usually go study the problem and then define the way that you can perform. Let's say you want to calculate the area of rectangle. So you go straight away, you write the equation, you put the input in there, you substitute them. If you want to request the input from the user, you do so, and then you get the output. That's it, straightforward. Now here, it's not the same way. If we're talking, for example, about prediction, so how do you get the equation, right? How you get the equation? Can you search on the internet, for example, looking for the equation of car prediction, like the rectangle, and then just bring it there from there and put it on the machine, write it, substitute numbers? Of course not. We cannot, right? We cannot go to Google and write, please, I need the car prediction equation, or I need house prediction equation, like the rectangle, straight away. Just you go substitute and you get it. It's not that way. And actually for two reasons, it's not that way, because it has so many factors included. And it also may differ from one country to another, from one region to another. There are many things. For example, if you talk about house prediction in Kuala Lumpur, or let's say in Kampar, they're not same. You cannot have one equation, use it anywhere, get the price, right? Of course, anyone, if you ask anyone, you tell him, I want to rent an apartment in Kuala Lumpur, it will be, I mean, intuitively, he will tell you it's way more expensive than Kampar, right? Or if you want to purchase a house. So there are so many factors. What I'm trying to say, there are so many factors included. It's not that much easy like you think calculating the area of rectangle. Now, how to find this equation, this suitable equation, let's say, that fits for this data, for Kampar, for a particular region, for a country, and etc. So how do you do it? Right? So we need some way to teach the PC how to find it, how to get it into it. Now, when we need to do that, we need to apply, for example, some sort of statistics in order to find something, in order to build a model that can understand or can actually do prediction. So this is why it says is not explicitly programmed. You need to do some other fields. You need to add in statistics, for example. You need to teach the application how to find that equation. So it's not explicitly there, right? You need, there's a learning stage. You need to teach it itself to the PC in order to be able to have future prediction. It's not like the equation. You don't need to teach the PC, for example, how to calculate the area, do you? Right? The equation is there. Just you bring it to the PC, substitute, and that's it. But here it's not the same. We need to find a way to teach the PC to learn. So this is why it says the ability to learn without being explicitly programmed. I cannot tell the PC, coming, or while I'm developing, well, this is the equation for car prediction, for example. It's not that way. So I cannot say it, I cannot tell it because I don't have it. So I don't have the ability to explicitly write a program to the PC to tell him or to tell the PC how to predict the car or the house price. I cannot. So this is why it says without being explicitly programmed. I cannot, actually I cannot. Right? So I need to teach him how to learn. Then he can use this algorithm, how to learn, to find it himself, to find that equation. If we're talking about regression later, we're going to talk about what is regression and the types that we may perform when we talk about machine learning or data mining. And by the way, guys, if I'm talking too fast, just let me know as well. Sometimes just I keep talking, well, it might be fast for you to digest. So also that's fine. Just let me know to slow down. Is it clear? What does it mean without being explicitly programmed? I know most of you has chosen that answer, but I'm not sure if you were really understanding what it means. I hope now it's clearer. Any question? So again, we don't have the ability to tell the PC explicitly how to do future prediction, but I can teach him to learn how to learn. How I only introduce him the historical data and I tell him, well, this is the data and here how you can learn. Try to find something. This is the way of learning. And then the PC will start to learn, apply that algorithm, and hopefully he can find that mysterious equation that would use it to apply later to find you the future prediction. Is it clear, guys? I don't see anyone writing anything. Are you lost? Feel free to ask. If you don't understand, that's completely fine, because I might assume my explanation is okay, but maybe it's not. Maybe I need to make it more simple or repeat. So that's fine. Just let me know. Is okay? Hi, hi. Okay, great. As I said, always there's no stupid question. Any question comes to your mind, you feel like there's doubt about it, not clear, so you may just let me know. So now I hope you understand what does it mean without being explicitly programmed. And later, actually, I wish I had the pen pen tablet. I would draw it to you. So how actually we can find, for example, the equation by using statistics. So we teach the PC the ability to learn, and then hopefully he will utilize the learning algorithm or the way that he's supposed to do, and then he will come up with something that would help him. That something, of course, it depends on what we are, depends on the task. So if it's regression, so he will find that equation. As I said, the mysterious equation that we do not know. As I said, there is no one fit standard. And there are so many factors. And also in some example, it may include so many factors. Now, if you tell me about house prediction, for example, it might be easier, right? Because you can ask about the house prices of this area, right? See the number of rooms, etc., the location near to the bus station or near to the train station, etc. And you can guess by yourself. You don't need to build a program, right? Maybe someone will tell you, come on, you're wasting your time. It's easy. Of course, you can argue or you can say two things. First, moving or transferring this knowledge to the PC is not easy as you think, right? We need how you tell the PC. If you write a program without applying machine learning or data mining, what do you tell the PC? If the price in this range, then maybe the future price will be like this. Sorry, if the number of rooms is like this, then the future is like this. Then if the location is near, if the area or the area, I mean, the size of the house is big or room small, and etc. So there you would write so many things, and things will get even more complicated, more than you can imagine. As I said, sometimes the case you are working on may include 100 or 1,000 of factors. So how you can write that if you need to use if condition, for example, inside your application to predict it will be so much hectic work, or even sometimes if it's very complex, it's impossible. It's impossible because if it's complex, we wish or we hope that the machine learning will be able to do it, to come up with the solution. So how would be the traditional way of programming? Okay, here is also another definition, is a computer program is said to learn from experience E. So now we keep this in mind, experience. What does experience means? With respect to some task T and some performance measure P. If its performance on T, which is the task, as measured by P, improves with experience E. So simply, let's substitute these mysterious words, experience, task, performance. So experience simply is the historic data. So hopefully, as we were saying, a computer program is set to learn from historical data, the training data. So in precise, experience means here the training data that you introduce to the PC, to the model to learn. With respect to some task, you have a particular objective task to do. Let's say house prediction. This is your task. And some performance measure P. Now, this is something we need to keep in mind. If we have some training data and we build a model, is that enough? Just that's it. We say, okay, I gathered historical data about the house prices and I build up my model to predict. Then the first thing I would say maybe, or someone can ask how good your model is, right? How good? Have you tested it? Have you tried really to predict for house prices in your area or based on the application you are building, maybe in certain region or not, right? So this is, we would ask naturally how good your model is. So you start testing. So the point is we need some way to measure how good or how bad our model is. So here comes the element performance measure, P, because this can be used as indicator while we are teaching the PC or the building up the model. So we can use that performance measure and tell the model or see how good or how bad. So if he is bad, then we need to keep learning, right? We still need to learn more or to find maybe some other algorithm. Maybe this algorithm doesn't fit well to the data, or maybe the data has problems. So there are so many things we need to start dive and dig into if the performance is bad. So the performance is like the indicator to see, to measure how good or how bad we are performing. Okay, so again, we have three elements: experience, which is the training data that we introduce to the model, to the application that we are working on. With respect to some task, of course, we have some objective we are doing. We're just introducing any data. That data is meant historical data for houses, because the task is we need to predict the future price for another house is meant to be sold, for example, right? So again, experience is training data. Task is the task simply you are working on, and some performance measure. We need that element, as I said, to measure how good or how bad our model is performing. Okay, so if its performance on T as measured by P improves with experience E. So of course, because this data, the model will use it to learn to improve the performance, right, on that particular task. Okay, so keep that in mind if you come again to this. Now, this is another definition. So you see there are many definitions actually, and this from Microsoft. So data mining is also called predictive analytics, and machine learning use well-researched statistical principle to discover patterns in your data. Again, this is why we are using statistical principles. Like, for example, we will see later when we work on regression, we are actually applying statistics. But why we are doing regression? Because we need to find that mysterious equation I just was talking about earlier, right? So this is why it's not explicitly programmed. We're going to another field. We're going to statistics. And then we're trying to find that mysterious equation using statistics that hopefully when we apply for future observations, okay, so it's good we start using these terms, future observations or future cases, to have a good prediction. So you see the word good, that means the performance. The performance is good for my model. That means is able to predict very well. Or it may be very bad. So later we're going to see what are the challenges that we may encounter when we come to data mining or machine learning. Okay, so keep in mind, not explicitly programmed. We are using some other way. We're only teaching the PC how to learn. We applying statistical principles, right, to discover some patterns inside our data that he can use later to predict for future. So we're going actually in totally another way than the traditional way of programming. We are applying statistics. For example, we are using logistic regression or linear regression. So we're coming later to explain about what these terms mean. But the idea is we are applying statistical principles to discover some patterns. So if I'm talking about linear regression, that means I'm looking for the mysterious equation. That equation will help me to predict for future price. So once I find this equation, I can just substitute, like similar to the case of area, calculating the area for let's say a rectangle. I just substitute inside that equation and it will give me y, because y is the important thing that I'm after, right? Is the value, the future observation or the future outcome for a particular observation. Okay, guys. Let's take an example, spam emails, and let's see how you would do it using traditional way of programming or using machine learning or data mining. So if let's say you are interested to build an application that is able to flag emails, whether it's normal or what they call it, non-spam or ham email, and against actual spam emails, right? So we need to teach a program, or let's say we need to build a program that is able to flag each email, whether it's spam or ham, like when you open your inbox, right, the email inbox, and you will see you have different categories. You have, let's say, ham, which is the emails you will normally check upon. And then if you miss out some emails, sometimes we go to the spam folder to look. Okay, so who has decided which email to go to which place, right? So that means there's some algorithm behind is working to filter out or to see, to flag which email is supposed to go to your inbox and which email should actually be sent to the spam folder. Now, if you want, so again, if we take the just definition we said there, where we have the elements experience, task, and performance, right? So now our task is to flag emails, whether they are spam or ham. Now the experience is the training data. That means we need to fetch all the previous emails we have, with the one with actual spam and the one that is ham, and introduce it to the PC. Or even if you are building a traditional program, then you need that data in order to try to find something. So you sit down by yourself and try to identify something, how to identify those emails, that the spam emails, and how to identify the emails that are ham email or non-spam emails. And of course, we need the performance measure to see, let's say, for example, we take the performance measure P is the ratio of correctly classifying emails to spam and non-spam, for example. So we need that, that performance. As I said, we need it to see how good we are doing. So now in the traditional approach, what would you do? In traditional approach, of course, you need to study the problem, right? You need to understand the problem that you are working on. So the problem is we need to build a spam filter. So you start to understand. How do you understand? Let's say you collect historical data, you bring spam emails, non-spam emails, you sit down, you try to find some patterns. Let's say if a person wrote this phrase or if the person wrote this keyword, So that means this is spam emails. If these keywords were not found inside the email, so this is, let's say, non-spam email. So now I'm talking about traditional approach, by the way. There is no data mining or machine learning element. I'm talking just in the way that if you just open up any language you are already familiar with and start writing a program to flag those emails, whether they are spam or non-spam emails. So you try to identify, find, for example, keywords or phrases exist inside the spam email. And then what do you do? Then it comes to write those rules. So after you found these phrases, these keywords, then you go to your application and write these rules. So implement what you have found earlier during the, let's say, studying the problem phase. And then you write your application, writing these rules. After you write these rules, it comes to the time where you need to evaluate, to measure, right? The element P, we need to measure how good or how bad. Now, if we are satisfied, and you would be so lucky from first time to do it, then just you need to launch your application, your app is ready to go. Correct? You are happy. Otherwise, if you are sad, what do? You need to go back and analyze the errors. Why you're not able to do well, right? Why your application is not working as intended to do. And then you go again to study the problem, amend those rules. For example, you have written inside your application and you go again to evaluation phase, and most likely you will fail probably, who knows. And then if you are good, then again, you go to launch. Otherwise, again, you go analyze the errors, maybe bring more emails, understand why those emails have been, for example, triggered or flagged as spam while they are ham, or while they are ham, flagged as ham while they are spam, and etc. You start again analyzing these errors and again study the problem, writing rules again, and so on. So this is someone speaking.
300到400，我们赶到货的时候是这款咯。
Okay. Okay, any question? I think all of you familiar with it, right? About traditional approach. So just here, the steps are written to you, but actually just now what I have explained. So the step 1, you investigate spam emails to find words or keywords or phrases. Then step 2 comes where you write an algorithm to detect these patterns and phrases inside the text, inside the emails. And finally, you test step 1, step 2, see the output, whether what you have done is correct or not, and keep going, keep repeating step 1 and step 2 until everything is good, until you are good and satisfied that the application you have wrote or you have written is ready to go. So this is the traditional approach. Let's see what's the difference. So the difference is, as we said, we need, when it comes to data mining approach, right, or machine learning, we need to teach or to program the PC how to learn from this data. So in this case, actually, most of the steps are just same, but here it comes to the heart of the work. So instead of writing those rules explicitly, right, remember the word explicitly programmed. So instead of writing these rules explicitly inside the application based on the keywords and the phrases, what do? We use some statistical approaches, some machine learning algorithms to learn by itself based on the data. So we give this data, and instead of taking this data myself and try to figure out, find some keywords and phrases, well, I use some of these algorithms. These algorithms will try to help me to find some way to flag or to figure out whether such email is a spam or not. Right, and this is called classification problem in this case, where anyway, we're coming later to discuss about the types of machine learning. So the idea, the changes is here. So instead of writing these rules explicitly, now what I do, I take this data, I bring some algorithm And then I bring this data. Of course, the data, you do not just simply throw it to, I give the emails, put them in the text file and just throw them to the machine learning algorithm. It's not that simple. It's not that way just straight away. Of course, you need some data preparation. Later, we also talk about. But anyway, let's say I have prepared the data as the machine learning algorithm would like to have, right? For you, it's okay. You have the text, you sit down, you look at the text, you find these keywords, but machine learning algorithms might not work the same way to learn from the data. So later we're going to discuss about it. So anyway, but the data is there presented to the machine learning in the way machine learning favors, the machine learning algorithm favors, and then it will start to work on this data to find something, to find some patterns, or to find a way to figure out how to flag an email, whether it's a spam or not. And of course, if the afterward, we evaluate the solution. We still need to evaluate. Remember, we have the element of performance. Always we have experience, which is the training data. And then we have the task, right? The task is simply what we are working on to flag emails. And then we come to the performance element where we need to evaluate our the output of this training algorithm, whether it's good or not. The same thing. If it's not good, then we need to study the problem. Maybe we didn't have good data. Maybe the data is irrelevant, for example. Maybe we brought some data that is not actually relevant to the actual problem. So we need to find out what is the issue. But again, we're not looking explicitly to find those keywords. Again, this is different approach. So we need to figure out why the machine learning algorithm is not able to learn from the data. Maybe the data has noises. Maybe the data is irrelevant, as I said earlier. Maybe it's not so good to teach the algorithm. And we start to figure out what is the issue. And then maybe the algorithm we use is not good enough for this kind of problem. Then we use another algorithm and so on. Until we are happy with the case, then we launch our product or our application. Okay, so as it says here, automatically learns words and phrases from spam in comparison to those in ham emails. Later, we're going to talk about these algorithms. But again, keep in mind, we're not finding these keywords ourselves, let's say. I mean, we're not writing explicitly how, we're not writing these rules in comparison to the traditional programming way, traditional approach. And instead, we are preparing data. We're feeding this data to some algorithm, right? And then we're going forward. For example, again, if we go back to the example of house price prediction, then for example, we use training ML algorithm, linear regression. So linear regression is quite famous for such problems. Let's say if you have continuous output, like you're looking for the price. Later also we talk what is the difference between continuous and discrete. But anyway, we're looking for the house price. We use, for example, linear regression. So linear regression will take the data, right? And then we'll try to find, as I said, that mysterious equation. And then we evaluate. But how do we evaluate? That means we later also we will discuss about it. But simply we will give some cases to this algorithm after it has trained. Let's say after it has found this mysterious equation. Then we take some cases from the data, already those houses has been sold, but I don't, of course, I don't give the actual price. Just I tell, okay, this house, tell me how much it should be predicted to be sold. Then it will give you some figure. Then you can compare because this house is already has been sold, right? And then you can compare whether the prediction was good or bad. Then let's say it was good, then just simply, wow, that's great. Then you go to launch your application. If it's bad, then what do? You go sadly again analyze the problem. As I said, maybe there are some outliers. Later also we discuss about problems inside the data. Maybe the algorithm that we used is linear. As I said, maybe we need non-linear equation or non-linear regression. So we change the algorithm and then we come back again and we test. We evaluate, see how good now the algorithm is able to predict. If it's good, then ready to go. If not, then we go back and so on and so forth. Is it clear how things are work? How you see that how we are at least getting the mindset that there in traditional approach, we use traditional way, right? We look ourselves to the text. Let's say we are building spam email filter, and then we try to find keywords or phrases. But here we are using statistical approaches in order to find, as the example of house price, the equation, and then we test, we see how good or how bad. Any question, guys? So we have 63 members here. So I like to see the chat box is alive, pumping many messages. If you have a question also, you may say so. Okay, Angie has no question. The rest, only Angie? Okay. Okay, great. Now, another thing in data mining approach, and this which traditional approach misses, is in data mining or machine learning can be automated. What do we mean by automated? Automated means, let's say, again, back to the example of spam emails. Let's say the hackers who send those spam emails have changed their way or their style in writing inside the messages. So what would happen? All right, this is a good thing. Think about it. If you are writing your using traditional approach, and those hackers have changed their way of writing those emails. They change their styles. They use different keywords, different phrases. What would you do? In this case, let's say you need to go back, sit down, check those new style of emails from spammers and try to identify new keywords or new phrases and then amend your application again and launch it again. But on the other hand, if I'm using machine learning algorithms, actually I can make this process because I taught the PC how to learn. So why do I need to spend my time? Just I can make it automated every time. Let's say I got my, spam filter, the old one based on the old data before the spammers noticed to change their way of writing. I have already built that model, right? I have already taught the PC how to do it. So now what I need to do, just I take new data and feed it again to the machine learning algorithm. And again, let it again figure out what to do. So keeping this in mind, actually, this is something new here, something good that the process can be automated. I don't need really to go back and do a lot of work. Just I can update the data, and then again train the model again. Of course, the need to train, but again, the process is already there. Just I prepare the data or I update my data and then feed it again to the algorithm to find, let's say the house prices had changed dramatically. Something happened. Now, let's say the house was sold just 1 month ago, used to be sold these kind of houses, let's say 100K. Now suddenly something happened in the market, something dramatic, and the houses prices have jumped to 200K. The house 1 month ago was 100K, now it's 200K. Then what I need to do, I collect again, I updated the data, historic data I got for the houses that has been sold, and then I feed it again to the linear regression, for example, and then the linear regression will find another mysterious equation. So you see now, actually, there's no fitted one equation that you can use, for example, especially when I talk about linear regression, and it's my favorite subject because it's easy to understand when we compare to the traditional, like calculating the area. So now I feed the new data to the machine learning algorithm, the linear regression. Linear regression will find another line or maybe updated it, not so far from the old equation, but it has some tuning, some changes. And then again, I evaluate, I'm ready to go. Excuse me. So the idea is machine learning is able to be automated, while traditional approach will be hectic, right? And simply it might be, let's say you spend 1 month writing traditional program, and then all of the sudden the spammers have changed their way of styling. So simply you have to stop there and spend 1 month to figure out, or maybe 1 week, and then only then you need to write the rules again, amend them, change them, and then launch your application again. While here, I can just make it automated process. Now, I just said earlier that we do not feed, for example, if we take the spam filter, later we say what classifier is, but the point is we do not just simply feed the algorithm with the data as simply you do, right? It's not just the way I give you the text. This is just something to keep in mind. So later we will come again, we will talk a lot about it. But algorithms usually favors numbers. Always PC likes numbers. So you need to find a way to represent those messages, regardless whether they are spam or ham, whatever those emails I have, I need to present them in numbers. So now just keep in mind, for example, if you need to present, let's say all the emails, let's say have this sentence, hello, how are you? Now, let's say I got an email says, hello, you. So what do I do? How to present this one? So the first one, if the all emails, let's say I have presented them hello with 1001. Yeah, for all the words, because here, if you check, I have hello, right? How are you? And then I will use these words. Okay, even if you don't understand it, that's fine. Again, we will come across it later on. So I will present them, let's say in a vector, saying 1001. The idea is, regardless whether this fits this or not, that we have two approaches. So either, okay, if you check here, how many words I have distinct word? I have hello, I have how, and are, and you. Now I have hello, you, right? I think here I missed also something I have to add. But anyway, so hello will take 1. That means it is presented inside the message. Because here I have hello, here I have hello. Let's say this is like the template for all the vector messages, right? That means the first location inside the vector for hello. The second location is for how, and then are, and then you. Now compare here, I have hello, hello. That means I put 1. There is a present for the word hello. Then hello again, just I keep it 1. If my vector is meant to be binary, like 1 and 0 only. And then I come to you. You, the location for you is at the end of this template, let's say, which is at the end of the vector. So I put 1. Okay, so is it clear? This is like a template. This is the master template that you use to build vectors, because as I was just saying earlier, we cannot feed text or just the same way you understand or read to the algorithms. And PC, when we talk about PC, favors numbers. So we need to find a way to represent our data to numbers. So this is one of the way. If we represent them in binary representation, so we should have some reference. So the reference is like the template. And then we got a message says, hello, you. Then I compare this with the template. So hello location at the first. So I put 1. Hello again. But since I'm working on binary representation, that means either 0 or 1. You cannot have more than that. So still 1. And then I don't have how are, right? I don't have them. So I put 0, 0. Based on the master template, remember? And then I come to you. You is at the location of the last element inside the vector, so I put 1. So this is using binary representation. Or I can actually use another presentation based on the occurrence. That means how many times even the word has appeared inside the email. So as an example here, still same example, hello has appeared twice. So I put 2. Now I'm no longer using binary representation, but occurrence presentation based on occurrence, how many times. And then it comes to The next had these two words based on the master template. They are not there. So I put 0, 0, still 0, 0, nothing changed. And U has occurred only single time. So I put 1. Okay, is it clear? So this is just something to keep in mind how we are feeding the data. So this is why I said there is element there is data preparation. It's not simply I gathered the emails and then just throw them to the machine learning algorithm like this. And then what to do? It's not something magic should happen. So you still need to work. So traditional approach, we don't need really to worry about probably data preparation. Just we do it, we write the rules, and then we check, we make text matches inside our emails to see if these keywords are there or not. But now the way is different. We need to present these texts in a way that the PC or the algorithm can function. So we use either, for example, if we're talking about text, then either we use binary representation, for example, or we can use the number of occurrences. So now I have the vectors. Let's say I have prepared the vectors for my emails. Then I feed them to the algorithm. I feed them to the algorithm, and the algorithm will follow the steps of learning how to find some output, as I was saying earlier, which would help later to what? To flag the new emails, to predict. Let's say later after I build my model, then suddenly I have received a new email, let's say from Angie. And then my algorithm, now it's built, it's already trained, right? So my algorithm will take the input from Angie, what she has written, and then will figure out whether this email is a spam or ham. Since it's from Angie, so most likely it's ham. So the algorithm is supposed to flag this email as ham, and it will go to my inbox. Let's say one spammer wanted to trick me, so he wrote some email and sent it. Now the algorithm, again, and one matter, always when you need to feed the algorithm, you need to have vector. For example, if we're talking about the example of spam filter. So even if I got a new email, I don't again throw it the same idea. I got the new email, I do data preparation, and then I feed it. I tell the algorithm, the model that has learned earlier, please can you predict whether this is spam or ham? And based on the result, you take the action to send the email either or to put it inside the inbox or spam. Since it was sent from spammer, so most likely is not going to be a good person dealing with me. So the excuse me. So most likely the machine learning algorithm will figure out that this is a spam, supposed to be, again, based on P performance, the measure. But that one was during training. So now no need to think about it. But later I can actually still check upon the model to see how good. Let's say I have, after the model has checked, says this is spam. Okay, send back. Later I can still actually check these my emails, let's say, and I say, well, yes, this is spam and nothing changes. But maybe if, let's say if the email is meant not to be spam, but went there, probably later I can take again the new updated, remember the new updated historical data and feed it again to the model to learn better, because maybe he's doing so much, sending a lot of emails, let's say, to the spam folder, and I'm not happy with that, where they're supposed to go to the inbox. So I gather, I update the data and then feed it again to the algorithm, or maybe I go and check why the algorithm is not working so well. Okay, anyway, just keep in mind, this is an example how you do data representation. Jason, he's surprised that there's no question. Why, Jason? Do you have any question? Jason, do you have any question? Okay, if you have, feel free. Okay, now we come to, again, all of this, just we are emphasizing why data mining or machine learning is important. I know that it's intuitively, we will say it's important, right? We don't need to argue much, but let's just, I mean, conceptually think how actually data mining or machine learning can benefit us. So firstly, for existing solution, let's say you already have existing solution like spam filter, for example, you already have followed the traditional approach, you build up spam filter. So existing solution, that's fine, but would you think that writing another solution using machine learning would be worthy? Actually, the answer is yes. Like when we come to the fluctuating environment or when we have updated data, things are changing, spammers are changing their style. So instead of using traditional and spend a lot of time changing and writing rules, I actually, even if you ask me, just thinking about writing rules would be a hectic thing, and I hated most when I use many if condition inside my application. I hated. So I even try to not to have many levels of if, but I hate it anyway. But I'm just saying you how you may think even applying machine learning might be simpler solution. So even if I have existing solution, I'm might still interested to move to data mining solution. Now, complex problems, for some problems, even using traditional approach would be impossible. For example, if you have a case where it involves so many factors, when we talk about house price, maybe number of rooms, the area, right? Maybe the location, how far or how near to the train station, to the bus station. Okay, maybe still manageable somehow, right? You can even figure yourself later about the price, maybe the area, KL, compare, etc. But some problems are so complex, so complex. Maybe you need to figure out when is the appropriate time, or let's say you have a factory and then the machinery needs some maintenance, right? They might be broken down. They need to change some, let's say, particular part of the machine, but you need to predict when the lifespan or lifetime for this part is coming to end soon. So how you do that? If you think about it, if I give you a part of the machine, I tell me when is the appropriate time to change. Maybe you will tell me, okay, based on historic data, sometimes the parts need to be changed every 2 months, or maybe 1 month or 3 months. Then let's take just the average and every 1.5 months and change it. Okay, this is one solution, right? You're following, let's say, just based on the data you're checking. Sometimes we need to change the part. This gets spoiled or broken after 3 months or after 2 months or after 1 month, or maybe even after 1 year. Let's make it worse. And now you come up, okay, well, say, what do you do? 1 month or 1 year? So how to decide? Even if you take, let's say, taking the average, say, well, 6 months, maybe the part will be broken even earlier because 1 month. So what do? You say, okay, let's change it every 20 days. This is even worse because you're putting a lot of cost on the factory. Maybe the lifespan for the part, that part hasn't ended yet. You still can use it for another 10 months. So that means it's a very complex problem. How would you figure out, how would you understand when it is the time to change? So traditional approach, that means just it's out of the question. We put it away. We cannot do it. And we hope for machine learning to perhaps find some solution for that, right? So this is about complex problem. Complex problem, again, traditional approach might come out of the question to apply. Fluctuating environments. Fluctuating environments, let's say like the example of spammers, they change their style, right? So machine learning, again, can be automated. Or maybe the stock price. Stock price is changing so fast, maybe sometimes. Then what do to predict? That means you need to stay behind the PC all the time. The prices goes up and down. So fluctuating environment. So again, data mining is good because we can make the process automated, correct? And then we can take the new data and make the changes to the model that we are using. Or getting insights. We have data and then we are interested to get some insights about the data. For example, you gathered about the food consumption for the country, let's say inside Malaysia, for many parts of it, Kampar, KL, and etc. And you like to get some insight. Maybe on average, let's say you may come up with some figures like on average how much every family will consume potato, for example, or tomato, or vegetables, or fish, and etc. But if you like to get insights, for example, certain states, maybe they consume a lot in certain time, and other states consume certain types of food and etc. Or different countries, let's say, you try to find some insights. Just you look to some insights, which country maybe consume a lot in certain time, in certain area, for example, etc. So these machine learning and data mining is still good to give you some insights. For example, you can apply principal component analysis. Probably we come later to it. If you have so many factors, principal component will try to reduce them to smaller number of factors, but at the same time, these factors are still representative for the other factors. So assume I have 100 factor. As I was saying, for example, consumption of vegetables for this state and other states and other states. And then I have, so one factor, consumption of vegetables, consumption of meat, consumption of something else, and etc. And then let's say I have 10 factors, 20 factors. And then I can, if I need to get inside so fast or by myself, let's say, I need to sit down and read these figures and numbers and see how they are changing. But for example, applying principal component analysis actually can reduce the number of factors. It will look to these 20 factors and make them only 2. So now checking 2 factors easier or having the 20 factors. So by only using 2 factors, I can get insights, for example, about these different factors by only using 2 or 3 or 4 instead of having 20. Okay, so even machine learning can still give us some insights. Okay, so now also some motivating challenges. Actually, it's still like related what now just I was saying. Why traditional technique may be unsuitable. So large scale. Now the data is becoming so huge, right? It's not just matter of house prices. Maybe you have a bunch list, 10, 50, but if you have millions, then what do you do? What do you do, right? Becomes like a very complex problem and just you throw it away. You cannot deal with it. Let's say you need the prediction to be so accurate. So you have you have gathered data and then you need to sit down and look. Actually, it's impossible. Even if you think you have millions of records, then how do you do? So the larger scale, the data now becomes so huge. We cannot just simply use traditional technique to come up with a solution. Or high dimensional. High dimensional, that means you have so many factors can be used to determine the prediction. So many factors, like when I use the example of, let's say, the maintenance part for companies, right? For parts, if they need to change the machinery parts. Then actually this may involve so many factors. Factors mean a column, or how could I say, factor like number of rooms. If we're talking about the house prices, when I say factor, also keep this in mind, means, or attribute, means I'm referring to the column. If I'm talking about table, I'm talking about the column, like number of rooms. How far is it in kilometers from train station? How far it is from bus station, and etc. So each one of these is considered factor. Okay, is it clear? When I say factor or dimension, also same. Factor or dimension or attribute, simply you can refer to, or column, the name of the column inside a table, same. Now back to the example, high dimensional, that means you have so many factors, so many attributes that would contribute to the fact of finding a prediction. So imagine you have so many factors. So again, traditional technique might not be suitable, so we go to machine learning or data mining. Heterogeneous and complex data. Now data may not be homogeneous, maybe just numbers. It may involve text, video, audio, links, all right, so many things. So even the data is becoming heterogeneous and complex and distributed. Distributed, maybe the data also not located on one part, on one location, one PC. It may be also distributed on so many areas, right? So we need also a mechanism, a way to work out all these. I think I will stop here. And then I'm going to launch the same questions again. And you need to answer them before we end today. If you have any question, please write in the chat box. And as I say, don't worry, nothing gonna happen, and there's no stupid question. Keep this in mind when you come to my class. Any question? Let's see. Okay, good. I see many of you have changed some answers. Yeah, that's very good. All of you so far has answered the question correctly, 100%. Okay, very good. So hopefully now you can go and argue. If someone says, well, AI is not so good, it's just we throw money in there and then what to do. So you can talk about the challenges. Some problems really, they cannot be solved by traditional approaches or automated, right? This is another good thing, automated, complex issues. What else we mentioned? Fluctuating environments, right? Like if we talk about the stock prices fluctuating, then what do you do? Or getting insights. Okay, very good. All of you has answered the questions correctly until now. Though the first question, no many participants. Okay, 40. Okay, please answer for the rest who haven't answered this question. I like to see all of you. As I said, this also will give me a hint saying how you are doing. That will actually motivate me to do even to talk more or to explain more. So when I see you are active inside my class, that is better. I said, feel free, you have problem, ask me. And let me see about the Outlook groups. Please make sure all of you has already there. Until now, 53. Guys, don't forget, again, the Outlook group and the other groups, please join. It's important. So later we don't need to, you can get notification, you can see the calendar, you can see the recorded videos, correct? So please, until now I have 53, I think should be even more. So please make sure you join. So I'm going to, again, put them in the chat box. Okay, good. Do you have any question? Mingchen, Angie.
No questions, sir.
Okay. Woon, WC, Warren, Sonia, Peter, Chanyen, Kelvin,
No
SF.
problem.
Okay, good. And as I said, if you have a question, feel free. You can post it inside the Facebook. Let's just have fun. Okay. If you don't understand, you feel like something, you need more explanation, also feel free. That's fine. because also I like to see where we are. The connection between us is good. Okay, sure, Mingchen. Actually, the class is finished here also as well. So if you have another class, feel free to join. And don't forget to join the groups and WhatsApp and Facebook. The attendance code already posted. Yes, at the beginning, I already posted it. Here, where is it? Okay, welcome. Okay, guys, then see you. So next week, Chinese New Year, right? So happy Chinese New Year for those who are celebrating. And Wednesday, we are off, right? So later I will tell you about replacement. For Thursday, also I might be not available, so I'll tell you about replacement class for Thursday. But for now, Thursday is still on. So this is why we have many channels. We can stay in touch. You are very welcome, guys, all of you. I can't read the code. Okay, wait, Peter, then I'll post it again. Okay, welcome, guys. Okay, here, Peter, the QR.